One side of Saturn's moon Iapetus is pitch black, the other bright white. It looks like a cosmic yin-yang, but there's a lot more to this moon than meets the eye. What makes Iapetus look like a giant Oreo cookie? And could there be a secret reason behind its two-tone coloring? When Galileo Galilei discovered the planet Saturn's largest moon Titan in 1610, he also noticed another small moon that he named Iapetus after one of the Titans. He knew it was a moon of Saturn because it was close enough to the planet that you could see its motion between Galileo's telescopic view and our modern telescopic views. We know a lot more about Iapetus, including the fact that it has a very cool two-tone appearance. The leading hypothesis for the black and white colors comes down to a pretty simple explanation. As we learned in school, black objects absorb all visible light wavelengths while white objects reflect them all. In space, things are usually some shade of gray, and they tend to be that color all over. That's because most objects in our solar system are made of rock and metal, which have a lot of different minerals in them. These minerals absorb certain wavelengths of light and reflect others, creating a particular hue. But Iapetus doesn't seem to care about any of that. Its dark side is truly black, and its light side is truly white. The line dividing the two is so sharp that it looks like someone took an Oreo cookie and put it sideways. In 2004, NASA's Cassini orbiter came close enough to Iapetus to take high-resolution photos of its surface. Cassini saw that the dark side of the moon had craters just like the rest of the moons and planets in the solar system. This suggests that its surface is made of rock like everybody else's, so why doesn't it look like it? There are a couple possible explanations for Iapetus's mysterious coloring. The first has to do with what happens when a small object orbits around a larger one. As Iapetus goes around Saturn, every 79 days, its gravity pulls up long streaks of dust off the gas giant's rings. It's not too surprising that a moon would leave streaks in a ring, because Jupiter's moon Ganymede does the same thing. But the dust lifted by Ganymede condenses into clouds of ice crystals on the dark side of the moon. On Iapetus, the dust gets trapped and builds up over time until it's several meters deep. In places where the dust isn't disturbed, it creates the dark spots seen on the moon's surface. The light side stays white because it gets blown clean of dust by the solar wind. So this hypothesis says that the dark stuff on Iapetus is actually just dust from Saturn's rings. But there's evidence against the dust hypothesis. If these dark patches were really just dust on the surface, then they should be smooth. Over billions of years, the sheer number of collisions Iapetus experiences should have smoothed out any big features on its surface. But the craters indicate that the dark material is part of the moon itself, at least down to a depth of a few miles. Not only that, but if you calculate how much dust Iapetus has collected over the age of the solar system, it falls way short of the amount actually on the moon. Finally, if the dust is only a few meters deep, then it shouldn't obscure the light coming from below. Yet some of the darkest regions are some of the brightest at night. So what's going on here? A second hypothesis proposes that the dark side of Iapetus is actually its night side. There's evidence for this too. When the team operating Cassini looked at the shape of Iapetus, they found that it wasn't quite symmetrical. The side facing away from Saturn bulges a bit in the middle. This means that the moon has a slow wobble in its orbit. The gravitational pull of Saturn is slightly stronger on one side than the other, which gives rise to this wobble and also creates a slight bulge. That asymmetry means that Iapetus doesn't present the same face to the sun all the time. In fact, the two sides only get equal amounts of sunlight once every 18 years during its orbit. If the dark side of Iapetus is actually its night side, then that would explain why the dark side stays dark and the light side stays light. For most of the year, one side is in daylight and the other in darkness. And in those extreme conditions, the surface material behaves differently. That could mean that the dark material is a form of ice that sublimates or transitions directly from solid to gas in the sunlight. But then why doesn't the light side sublimate? Perhaps the explanation lies in the difference in pressure. The side facing away from Saturn receives more sunlight and therefore has higher atmospheric pressure. If sublimation requires a certain pressure threshold, then only the darker regions would experience it. However, there's a problem with this hypothesis. If the dark side is made of ice, then it should be very cold. But measurements from Cassini say that the dark side is only about 30 degrees Celsius cooler than the light side. And if the dark side is experiencing less sunlight than the light side, then it should be even colder. So why isn't it? There's one last hypothesis that just might explain everything. Unlike the other moons of Saturn, Iapetus is believed to have formed elsewhere in the solar system and then gotten captured by the planet's gravity. This might help explain why it's so different from all the other moons. And it also might explain why the two sides are different from each other. If Iapetus started out somewhere hot and then migrated to its current orbit around Saturn, that could explain why its dark side doesn't sublimate. It also might explain why the dark side is darker and the light side is lighter. When Iapetus formed, the material on one side could have been exposed to more heat than the other. That would mean one side of the moon had more opportunity to oxidize or combine with oxygen. Most of the minerals in rock are metallic, so oxidation can turn them into different forms that are darker in color. If Iapetus really did start out somewhere hot, it could have been exposed to enough heat to create a layer of oxidized material on one side and a less oxidized layer on the other. This is supported by observations from Cassini. The color of Iapetus varies depending on the angle of the sunlight. This is similar to the color variations we see on Mars, which has a rusty color on the equator where the atmosphere is thicker, but a lighter color at the poles. On Mars, the dark color comes from iron oxide or rust. So, if Iapetus's dark color comes from iron oxide, that would support the captured moon hypothesis. Unfortunately, we don't have enough data to check whether iron oxide is actually on Iapetus. So the search for the real explanation behind Iapetus's two-tone coloring continues. The good news is we don't need a big answer to enjoy Iapetus's unique beauty. Whether it's an Oreo moon or an alien Yin-Yang, it's sure a sight to behold. In 2025, scientists expect that NASA's Dragonfly spacecraft will reach Saturn and explore Iapetus up close. Its lines collect data about the moon's atmosphere and land on the surface to analyze the composition of the soil. So stay tuned for updates. Maybe soon we lines know exactly why one side of Iapetus is so dark and the other so bright. If you want to learn more about Dragonfly and other missions to Saturn, check out the resources in the description, and thank you for watching.